So in topic 1 of unit 2, we learned the basic structure of the atom. So the locations of the protons and the neutrons and the electrons. And one of the last things that we talked about was a basic Bohr's model, where 2 electrons fit in the first shell, 8 in the second shell, 18 in the third shell. This next topic, we're going to spend the entire time talking about the arrangement of electrons and how we know where they're located, where that Bohr's model came from, and what our current theory is. So in this video, I'm just going to give a little bit of background information into quantum theory and discuss some experiments that have led us to what we now understand as the atom. So quantum theory began to take shape when Max Planck did some experiments. And essentially what he tried to do was he would heat up a metal, and when metals heat up, they glow, right? And when they glow, they're releasing light, and by releasing light, they're cooling off, because light is energy, and so if energy leaves, the thing cools down. So he thought that basically by allowing this object to glow, there would be this stream of heat, this gradual cooling of the temperature of the metal. But what we actually found was that instead of this nice, smooth sort of curve of that metal cooling sort of gradually, that it was actually more of a jagged line, and that the heat, it was cooling in little increments. And so he came up with this idea that energy isn't a continuous flow of things, it's actually these small little bundles or packets. And each of these packets has a certain value. And he called those little packets or those little bundles quantum. And that's where the quantum theory comes from. So, Max Planck didn't really believe that this could be possible, so he proposed the idea, but it was really Albert Einstein who came along, who designed an experiment and was able to prove Max Planck's theory. And the experiment that he did was called the photoelectric effect. And I'm not going to get too in detail about the photoelectric effect in chemistry, but if you take AP Physics, we do discuss a lot about the photoelectric effect. So essentially what he did was he would shine light at metal, and he would cause those electrons on the metal, in the atoms that make up the metal, to jump and to move. And so he was able to equate the kind of light and the wavelength of light that he shined at the electrons to how easily they jumped around. So by doing this research with light, Einstein determined that, well, light is a form of energy as well, and if energy comes in little packets, then light must be in little packets or particles. And he called those particles photons. And we know that light is a wave, but now Einstein also proved that light is a particle. And I'll talk a little bit more in detail about that, how those two things interrelate in a video coming up. But for now, just sort of understand the basic idea. So these little packets of light, we call them photons. So that idea of quanta being a little packet of energy, now we give it a special name because the little packet that we're talking about is light energy. So we call it a photon. So each photon carries a quantum of energy, which relates to the frequency of the light or the color of the light that you see. And again, I'll go into further detail about what that means in the next videos. So how does this relate to Bohr's model, right? So we learned that 2, 8, 18. So essentially what Bohr did was he made this model based on the fact that if you excited a element, so if you put some sort of energy into it, whether it was shining light like Einstein did, or if you light something on fire, or if you plug it into an electrical outlet, the electrons absorb a certain amount of energy and they start to jump around the atom, and they jump from one place to another, and as they jump, they release light. And So he was able to determine that electrons sort of existed in this certain space in the atom based on where they were jumping around. And so that's how we got the idea of these shells and how many electrons can fit into each energy level. So in order for an electron to jump, it would have to absorb a certain amount of energy. And that amount of energy it could absorb, like I said, from flame, like fire or electricity. And when it did that, it jumps up to what we call this excited state. And then when it falls back down from its excited state to what we call its ground state or its normal state, then it releases light. And we're actually going to do two different experiments where you're going to look at this and you're going to both qualitatively and quantitatively describe this sort of experiment. So this is the sort of the backbones to where Bohr's models came from. And in the next videos, we're going to look at this, which is in your reference table, and I'm going to explain it in terms of quantum theory and how to interpret this graph and answer questions about it for the test.